Hello, and welcome to the first lesson of Module 3, where we're going to multiply and divide in scientific notation. By the end of the lesson, I'll hope you'll be able to multiply and divide numbers in scientific notation and round your answer to the correct number of significant digits. So, simplify. A lot of people want to distribute this. So let's take 3 times 10 to the 5th and write that in standard notation, written out. That's 300,000. 6 times 300,000 is just a multiplication problem. We are not distributing here. Okay, don't look at this as distribute. Okay, these are not separated by addition or subtraction. It's one term. We're multiplying one term times one other term, just multiplication. This is what you would do for distribution. There's a plus sign there that separates, and you have two terms. 3x and 5 are two terms, so you would distribute that. So these two problems are different. All right, so we're going to actually do the problem now. What do? We do 6 times 3, which is 18. And we actually don't do anything to the base of 10. Just stays 10 to the 5th. Now, we got to make sure our answer is in scientific notation. So 118 is not between 1 and 10. So I got to move the decimal back between the 1 and the 8. When I do that, I make that number smaller. So I got to make the exponent bigger by 1. So 5, the exponent of 5 becomes exponent of 6. And that's my final answer. Okay, so we can check that. We could write it out in standard notation. 6 times 300,000 is 1.8 million. If I move the decimal, I have to move it 6 spots. It'd be 1.8 times 10 to the 6th, which matches up. What happens if I did distribute? So if I did 6 times 3 and got 18, and I did 6 times 10 and said 600,000. Well, 18 times 600,000 is 10,800,000, which when I write it in scientific notation is not the same. So this is not distribution. What happens when I have two numbers in scientific notation? In that previous example, we only had one. Well, these numbers have the same base of 10, so they can be multiplied. The way you do this is you take the coefficients a and b and multiply them together. So a times b, and then you take 10, which there's two 10s, so the same bases, so I add my exponents. So 10 to the x plus y. Now you round to the same number of significant digits as the number that has the smallest number of significant digits. That'll make more sense once we get to the next problem. All right, so here we go. We take the coefficients, 5.1 and 4.3, and multiply those together. Then we take the bases of 10 to the 4th and 10 to the negative 6th, and we add those together, or in this case, 4 plus negative 6 is 4 minus 6. 5.1 times 4.3 is 21.93, and then that's 10 to the negative 2nd. Again, we got to make sure this is in scientific notation, so I got to move the decimal one spot over. So 2.193 times 10 to the negative 1st. I made this number smaller. I got to make the exponent bigger by 1. So negative 2 plus 1 is negative 1. But I can't leave that. That's 4 significant digits there, 2, 1, 9, and 3. I only have 2 in each of my original starting numbers. So I can only have 2 in my final answer. So I round that. I look at the 1, I look at the number next to it, that's a 9, so I round that to 2, 2.2 times 10 to the negative 1st. Let's check that answer. Write them both in standard notation. So 5.1 times 10 to the 4th is 51,000. 4.3 times 10 to the negative 6th is a very small number. Multiply those together, you get 0.2193. Move the decimal over 1, and you get 2.2 times 10 to the negative 1st. All right, what about division? It's very similar to multiplication in that you just take your coefficients and you divide them. So negative 6.3 divided by 1.29. And then you take your exponents and you subtract, and you always subtract top minus bottom. So it's 2 minus 8. Negative 6.3 divided by 1.29 is negative 4.8837204 times 10 to the negative 6th. Now, the smallest number of significant digits up here was 2. Negative 6.3 has 2 significant digits. So I can only have 2 significant digits in my answer. So negative 4 point, the second digit's right there. I got to look at the one right after it to know whether I round up or keep it the same. This one rounds up to 4.9 or negative 4.9 times 10 to the negative 6th. That number is between 1 and 10, so I can leave it just like that. Check it. Negative 630, which is negative 6.3 times 10 to the 2nd, and 1.29 times 10 to the 8th. We're dividing those two numbers, and you get this answer, which if you translate that to scientific notation is what we got. All right, so a word problem here. In 2017, the population in the United States will be about, or was, 3.24 times 10 to the eighth. Spending for healthcare was about $10,345 per person. About how much did the United States spend on healthcare in 2017? We're going to use scientific notation. So let's get an idea of what's happening here. The healthcare cost per person times the number of people equals the total cost. So 10,345 per person. That's the healthcare cost. So we want to write that in scientific notation. That's 1.0345. I move the decimal 4 spots, and it's a big number, so that's 10 to the 4th. We already have number of people written in scientific notation. That's 3.24 times 10 to the 8th. We're going to figure out the total cost by multiplying those two together. 1.0345 times 3.24 is 3.35178. And then you add the exponents, you get 10 to the 12th. Now, the smallest number of significant digits is 3.24. That's 3. So I'm doing 3.35. I look at the number right after 5. It's 1. So I keep this the same. It's 3.35 times 10 to the 12th. If I write that out in standard notation just to see how big this number is, you can see that that's a very, very, very large number. Okay, and that concludes lesson 1 of week 3.